Hôm nay Trung tâm Đào tạo Quốc tế rất là vui mừng tổ chức cái khóa học về chuyên đề về AI để hỗ trợ cho cái nâng cao kiến thức chuyên ngành cho tất cả các bạn sinh viên của hệ đào tạo chất lượng cao của học viện, đặc biệt là các bạn sinh viên năm thứ 3 và năm thứ 4. Các em đã bước vào cái giai đoạn học tập chuyên ngành và tìm hiểu về định hướng nghề nghiệp. Thì khóa học về chuyên đề về AI, về phát hiện bất thường này là một khóa học chuyên sâu mà Trung tâm Đào tạo Quốc tế cũng mong muốn là cung cấp cho các em những cái kiến thức để các em tìm hiểu về cái định hướng nghề nghiệp công việc sau này của các em được tốt hơn. Đặc biệt đối với khóa học này thì Trung tâm Đào tạo Quốc tế muốn mời chuyên gia nước ngoài từ một cái trường đại học hàng đầu về công nghệ, nghiên cứu những xu hướng công nghệ mới trên thế giới đến để truyền đạt và chia sẻ với chúng ta để chúng ta có cái hiểu biết tiếp cận với công nghệ hiện đại trên thế giới. Đấy, thì những cái khóa học chuyên đề như thế này thì cũng là những cái chương trình đặc biệt dành riêng cho sinh viên chất lượng cao, và mong rằng là cái khóa học gồm có 3 buổi học, là buổi học của buổi sáng ngày hôm nay, buổi sáng ngày mai và buổi chiều ngày mai. Chương trình học của chúng ta sẽ là buổi sáng hôm nay bắt đầu rồi. Ngày mai thì là sẽ từ 9 giờ đến 12 giờ và chiều ngày mai thì từ 2 giờ đến 5 giờ. Mong rằng là các em sẽ tham dự các cái buổi học này đầy đủ để lĩnh hội được các cái kiến thức của khóa học đầy đủ. Đấy, và chúng ta sẽ có được những cái tìm hiểu và nghiên cứu chuyên sâu, cũng như là tiếp cận với chuyên gia quốc tế để chúng ta có cái hiểu biết mới, mở rộng kiến thức hơn. Cái học tập này không phải chỉ giới hạn trong cái lĩnh vực mà rất là sâu hẹp mà chúng ta được học ở trên trường, mà chúng ta có thể là mở rộng và tìm hiểu những kiến thức bên ngoài, là định hướng cái nghề nghiệp sau này cho tất cả các em. Đấy, thì cũng là rất là mong cái khóa học sẽ góp phần giúp ích cho các em trong quá trình học tập, cũng như là cái quá trình mà định hướng nghề nghiệp tới đây sau này. Đấy, thì để mà giảng dạy cho khóa học này, cũng như để thuyết giảng và trao đổi cùng các em, thì Trung tâm Đào tạo Quốc tế có mời đến là giáo sư Chung-Ang, là giảng viên và cũng là cái giảng viên cao cấp của trường đại học Chung-Ang Hàn Quốc, một trong những trường đại học về hàng đầu về truyền thông, công nghệ và truyền thông. Đấy, thì sẽ giảng dạy tiếp theo đây cho chúng ta. I would like to introduce Professor Chung-Ang from Chung-Ang University, Korea.
Thank you for your kind introduction. Is it okay? Everybody understand English, right? So I know that PTIT is one of the best universities in Vietnam. I'm really happy to be here to talk about my research, my experience on AI. And I have 2 hours or 2.5 hours. So today I'm going to talk about anomaly detection. So one of the typical problem in AI, you have a lot of data. You want to find out what is the, some kind of very strange patterns, right? This is really important to detect some useful patterns. For example, I'm coming here in this morning, I had 2 accidents on the traffic, right? I was really surprised. And for example, if you have an unmanned car, like a Tesla, for example, you need to have some kind of system to detect some accident, right? So anomaly detection is always important in AI. So again, I'm very happy to be here to share my experience with anomaly detection in AI. And so here is the title. It looks very general, but today I'm going to share very general, very basic concepts on AI for anomaly detections. And maybe tomorrow I'm going to talk about more applications with my experience. Okay? So, like she said, my name is Jason Jung. You can Google my name. So I'm from Chung-Ang University. You know, in the it's the university located in the center of Seoul city. So Seoul is the capital city of Seoul, Korea, and we have like 20,000 students in my university. Actually, my university was very strong with the arts and humanities, but nowadays people are always talk about AI, right? So AI, big data. So my university also focusing on how to improve the research in my university with AI, computer science, big data, and so on. And we are spending a lot of money, a lot of, you know, we are encouraging students to learn more AI. Maybe it will be the same in Vietnam, right? So it's always important. Okay, so, and also I have around 200 articles on SCI journals. I have very, you know, 200 articles. Well, you know, number of papers is always important, but I want to talk about some journals because we need to consider the quality of the papers. You know, so expert system with application, information fusion, information science. I'm not so sure how many students here, like a master student or PhD student, but if you want to focus on research, you have to consider not only the number of papers, but also the quality of papers, right? So please, you know. And I'm working, you know, as an editorial board in several international journals, like Information Fusion, Journal of Web Semantics, Information Processing and Management, and so on. And also I was working for Korean governments for AI. So in Vietnam, I know several government agencies. I don't remember the name, but so we call NRF. So I was one of the members in the Korean government. And I was a visiting professor in NII in Japan. And also I was in NTTU as a visiting professor in Ho Chi Minh City, like before Corona. And I was really had a good experience with the Vietnamese students, Vietnamese peoples, and so on. And well, very short introduction myself, okay? So this is my research interest. So the question is, how can we use AI to help people when you have a collaboration, you know? So how can we help people by using the AI techniques? Okay, so like recommendations, searchings, social networks always important, right? So this is my research question. How can AI help people to share their knowledge for collaboration? So now I'm in Vietnam, Hanoi City, and I want to have a collaboration with people in PTIT because it's always important to have a collaboration, right? So for the collaborations, we have to consider how can we represent your knowledge, right? So you know something, you want to share your knowledge with other people, and how can we share? It's always, you know, important. There is some kind of language problem, cultural problem, you know, many different, you know, problems. So how can we solve it? So nowadays people are talking about ontologies. Well, ontologies, now people are talking about knowledge graph. You want to represent your knowledge, and how can we share? Again, the social network analytics is also very important. So, you know, I have a lot of papers, a lot of ideas. How can we analyze our social network, like Twitter, Facebook, you know, LinkedIn, right? So we want to analyze our social network to have some good friends, good collaborators. The next one is the recommendation and negotiation. So you have a lot of data, right? So you need to have some good recommendation. I'm not so sure how many people are familiar with the Netflix. So you go to the Netflix, or even YouTube, you have a lot of recommendations. So because you have a lot of information, you need to find most relevant information, most relevant movies, for example, right? So it's recommendation and negotiation is always important. And finally, the data stream. So today's topic, right? So we have a lot of data from sensors. Even here, you will have some kind of sensors, right? In each room. On the street, there is a CCTV and computer. You know, you have the servers. There's a lot of data from clients, and you need to analyze this like data streams to find out some useful patterns. So particularly, we are interested in anomaly detection, so which is the topic for today, right? So here is the outline for my talk. So I want to share very, very basic concepts on anomaly detections. So what kind of techniques, what kind of methods we are talking for anomaly detections, okay? Okay, I want to check my time because the time is limited. After that, I want to talk about the anomaly detection with a multiple time series. Okay, so maybe this is some kind of new trends. Not only the single time series, but also if you have a multiple time series, like a multivariate time series. Okay, and after that, I will show you several applications. What kind of application can we consider with the anomaly detections? It's you know, for better understanding, you have to consider some application, right? And my experience, because I have tried to apply our ideas with several different domains, and like traffic congestion, and EEG, like a the signal from your brain. And most importantly, I want to emphasize the climate change. I'm not so sure in Vietnam, but in Korea, climate change is really, really important. The weather is changing over time, right? Nowadays, we have a very hot weather, very cold weather, and we want to find out the reason why the climate is changing. Because the weather data also time series, multivariate time series. So we want to apply anomaly detection with the weather data, and we try to understand the climate change from these methods. Okay. And finally, I want to discuss about open issues. Okay. So I don't want to. Well, I didn't expect this large number of students actually. When I have an invitation, I was thinking maybe 20 or 30 students for my talk. So I was really surprised. Now we have 200 students. So maybe I will talk about some open issues. So if you have any chance, you can extend the ideas for your research. I hope you can have some motivation from my talk. Okay, so I'm going to talk about the anomaly localization. This is also kind of new issue. Okay, so once you detect the anomaly detection, you want to find out where, why, how can we, improve the anomaly detections, and also very important issue like early detection. So you have a data, you detect anomalies after the event, right? But the goal is to detect the anomalies as early as possible. You know what I'm saying? Okay, so I'm going to talk about this open issues to have some kind of motivation for you guys. Okay, can you open the second file? So how many of you are master student or PhD student? How many of you? No? Most of bachelor student?
No master student.
Sorry?
No master or...
Okay. All undergraduate student. Which years? 2 years? Second year? Third years? Fourth years? No one? No one wants to talk, right? Okay. So, I'm not so sure how many of you are familiar with the AI, like, you know, supervised learning, unsupervised learning, classification, clustering, and so on. But, yep.
I'm junior, so those are junior student,
Okay.
like third year.
Okay. And there is another student behind you.
Okay, name's Tom. All right. Well, we had known about AI for quite a while actually, but personally for me, I only really started using AI when Microsoft implemented ChatGPT into their chatbot. So it's very powerful, but I'm not sold on the fact that it can do everything.
Yep, thank you very much. So I can assume that some of you are already familiar with AI, right? So if you are not familiar with AI, or maybe this is your first time to learn what is AI, maybe it will be a little bit difficult, but maybe I can assume that you're already familiar with AI, okay? I don't mind if you have any question, just raise your hand and give me the question, okay? We can discuss during my talk, okay? Don't mind, okay? Okay, so like I said, we want to talk about anomaly detections, okay? So what is anomalies? What is anomalies? In real world, in our real world, you know, we have a lot of applications. Like I said, on the traffic, on social network, you send an email, right? You receive a lot of emails, and in our real world, we have a lot of anomalies. On the traffic, for example, suddenly there is accidents, okay? This is some kind of anomaly. You have a lot of email from like, you know, but there is some kind of spam mail, okay? This is anomalies. So normal and abnormal, right? So anomalies is deviated data points from expected data patterns. Okay, so you always expect something normal, right? Always. You have the normal data over time, again and again and again, but sometimes suddenly you have a very strange pattern, right? You always receive the normal email from your friends, but sometimes you receive some spam email, right? This is abnormal, right? You know what I'm saying? Yeah? So this is abnormal. We have a lot of, you know, we have a lot of anomalies in our world, in your life, okay? Every time. So the question is, what is the anomaly detections? Okay, so you know normal and abnormal, right? And now you want to have some kind of AI system to detect your anomalies. Okay, how can we detect the spam emails? How can you detect the accident on the traffic more efficiently? Okay, so here is the anomaly detection. Is okay. There's no. Is to identify the anomalous labels of data in a given data set X. So this is just a formal description of the anomaly detection. Okay, so you have a lot of database or data set X, and you want to find out which records are anomalous, right? So the question is, can we detect the anomalies by using some kind of rules? Okay, for example, very simple example, the fire alarm. Maybe there is some fire alarms. If there is a fire in the building, there is a sprinkler. They will put some water because we want to stop the fires, right? So how can we make the fire alarm system? How can we make it? If you have, okay, in your house, in your home, there is a fire alarm system, right? And how can we make it? So, very simple idea. We can put some rules, okay? So, if there is a fire, we can say that the room temperature is greater than 80, right? So, this is a very simple rules. You can have this kind of rules to detect anomalies. You know what I'm saying? Very easy. So you can use some kind of rule. Okay? Otherwise, it's a normal. So the room temperature is not greater than 80. It's a normal, right? There's no fire. Okay? Okay. So you have to understand this example. I will use this example during my talk. Okay? Fire alarm. How can we decide 80? The temperature, room temperature is 80. How can we decide it? Who decided? Okay. How can we decide it? Experts, right? Experts. Experts decide, okay, maybe there is a fire, then the room temperature is greater than 80, right? You know what I'm saying? The experts. How this expert decide 80 as a temperature? How can they decide it? They have some kind of trial and error, right? They test, okay, they put some fire in the lab, okay? So whether it's 80, whether it's 100, whether it's 200, right? You know what I'm saying? Okay.
Yes.
Okay. But what is the optimal? What is optimal temperature? You know what I'm saying? Optimization. Optimization. You want to optimize the temperature. How can we do it? How can we optimize the temperature? Why 80? Why 75? Why not 75? Why not 100? So they need to repeat the experiments. They need to repeat, how can I say, they need to repeat the experiment with the different cases, right? Small building, like the room like this, very big buildings, okay? They need to repeat the trials, right? And then they will decide, okay, maybe this is a very optimal temperature to detect the fire, right? This is some kind of learning process. You know what I'm saying? The training. You have a lot of data. You want to detect the anomaly, right? By training. So in this case, human experts are learning, right? They will have more experience. They want to find out what is the optimal temperature for anomaly detection. Okay? Is it possible to train the AI system? You know what I'm saying?
I think it is possible.
So, sorry?
I think it is possible.
Yes. Thank you very much.
By, for example, we collect the data from some real files, and then we put it in the book, right? And then the machine can, when another accident happens, because the machine has learned about it, so they will detect the files. That's
Very
very
smart.
smart.
Very smart. Okay. That's good. That's good. Another question. Is it possible to, okay, maybe I'm going to talk about more details later on, but is it possible to have the fire alarm without the rules? What do you think? Okay, let's think about it, okay, during my talk. I don't want to give the answer right now, but we can consider. Like I said, there are so many applications with the anomaly detections. Okay, so the first example is intrusion detection. So IDS, right? Intrusion detection system. So some of you are familiar with the network security, right? So they want to detect the unauthorized access in computer networks. So if you are like an administrator of the server, right? So you need to protect your system from the hackers. There's a lot of attack from outside, right? Even in my lab, sometimes I have a lot of attack from China or some North Korea, and I want to protect our system, our data, right? So how can we do it? So there is like an IDS system, intrusion detection system, by analyzing the access load. Okay, within a very short time, you have a lot of access. This is anomalies, right? So you need to protect your system by using anomaly detection, okay, in computer network. And also very important, especially in Korea, we have a lot of financial issues nowadays. People want to, people try to make a very fake ID, like fake accounts. This is my cell phone, right? This is my cell phone. There is my financial information. Okay, I can pay something. I can withdraw my money, right? But sometimes, someone want to fake my ID, my accounts. Okay, and then they can have some fraud detection. Okay, they can have some fraud detection to identify. This is fake, this is not fake, okay? So credit cards and insurance claims, this is really, okay, nowadays we have a lot of issue in Korea. So like someone said, oh, I have an accident, I need the money from insurance company, right? So it's really important to detect. So what kind of data we can use? Here is the transaction history, okay? So a year ago, 2 years ago, there's no transaction, but this year he has a very strange transaction. Then this is some kind of fake ID, fake accounts. Okay. So fraud detection is also very important in the financial area. Okay. And healthcare and medical diagnosis. So AI. Really important for medical area, right? So we want to detect your disease, like a cancer or heart attack, seizure, this kind of medical disease. You have to detect earlier. Earlier than your like a big problem, right? So you can use some medical image like a MRI. Okay, so you go to hospital, you will have the MRI test, and then the result is some kind of three-dimensional image. Okay, like some kind of image data. Okay, and also you can consider EEG and ECG. You have some sensors in your brain or your hearts, your body, and we can have multivariate time series data. Okay, and doctors, the medical doctors can evaluate your condition, your health condition, and then you have some kind of problem, you have to some kind of treatments and so on. But instead of doctors, we want to have some kind of AI system, okay, for the medical diagnosis. Okay, and And also we have a lot of EHR data, like electronic health records, okay, for your medical condition. Okay. So like I said, a year ago, 2 years ago, your brain is okay, no problem. But this year you have very strange pattern in your brain, in your hearts. It means that you have some problem, right? So this is really important for the diagnosis with the anomaly detection. And another example, the IIoT, it's industrial IoT, also very important because you know, in the smart factories, they want to put some sensors in the factory to manage the process. You know what I'm saying? Like, I'm not so sure. You know the Hyundai Motors, right? So Kia, Hyundai. We have several well-known car manufacturers, and they have smart factories. Okay, they want to have some sensors, and they want to monitor whether the process is okay or not. Okay, it's a normal or abnormal. So from the factory, you have a data stream. Okay, and then you want to detect whether the machine is okay, normal or abnormal. If the machine is abnormal, you have to replace, right? Otherwise, you will have a really big problem. You have to stop your factory. Okay, it's really big problem for the factories. Yes, and also we can monitor the system behaviors. Okay, whether your system is working properly or not. Okay. Here the data is the data stream from the sensors, the IIoT. There is a lot of sensors. If you consider the engine or very complex mechanical systems, there is a sensor for the bearings. Okay, you have to measure the position of the bearing. If you have a lot of process, right, like 10 years, 20 years, you have to find out when you have to replace. You know what I'm saying? Otherwise, you will have a really big problem. Another very good example is security, right? So you have a CCTV everywhere, okay? Because I'm sorry, I'm just giving the examples in Korea. Most of the street there is a CCTV, okay? So whether there is accidents, we want to find out who is the problem, who made the mistake, okay? So CCTV and the black box on the car, okay? So we are using anomaly detection methods to find out who is the problem, okay? So in the CCTV, you want to identify the abnormal scenes, okay, in video records. Very easy, right? Very easy to understand as an example. Okay, another example with the Tesla. Okay, so really, I'm not so sure how many Tesla you have in Vietnam, but also, you know, we have a lot of a lot of Tesla in Korea, and this kind of autonomous vehicles, like autopilot system, is really getting more important than the past, right? So we need to detect whether there is an obstacle or not, whether there is a people, whether there is a bicycle. You have to detect by using the cameras. Okay, camera or lidar or radar. There is like a vision system, okay, to detect the obstacles. And also, like I said, they need to also detect the accident, right? Or road condition. If there is how can I say, some what is it? Some kind of I don't know how to say. some problem on the road, you have to detect it, right? So this is also kind of anomaly detection problem. Okay. So so far, I gave you many different examples. Okay. So anomaly detection can be applied many different applications. I'm pretty sure that in Vietnam will be also the same, right? If you are interested in this kind of problem, okay, you can apply your idea for anomaly detection in your application, okay? So here, intrusion detection for the networks, fraud detection for the finance, health and medical issues, and IIoT like smart factories, security and video surveillance like a CCTV and security, and autonomous vehicle, is getting more and more important. Okay, so not only this, but also there are a lot of different applications with anomaly detection. So please keep in mind, it's really, really important. I really want to emphasize that it is really, really important nowadays. Okay. So, what is the challenge? Okay, so some of you are already familiar with the AI, right? Also data mining, also statistics. Okay, so maybe you can ask me, okay, we can apply, some statistical model to detect anomalies, right? But now, why we are talking about AI? Okay, so here. Anomaly detection with a very simple model like a statistical models and so on cannot take fully supervised approach. Okay, like I said, the fire alarm system, the human expert decide 80%. 80 as a room temperature. Okay, but this is a fully supervised approach. Okay. But sometimes you will have a different situation. Okay, for example, some experts decide, okay, maybe we can decide room temperature with 80. Okay, but he had only the experience with a very big building. Okay. If you use this system for very small building, the 80 is not a good choice. You know what I'm saying? So sometimes it's good, but sometimes it's not good. It always depends on the situation. So it's not fully supervised. Sometimes it will be changed. Nobody knows. This is the problem. You know what I'm saying? So you have a classification system with the AI. You have a lot of training data set. You have a really nice AI system. It works very well. But what if there is a very exceptional case? What happens? You know what I'm saying? Please understand what I'm asking. It's really, really important. No. You don't need to give the mic. Okay, I want to give some chance to think. It's really, really important. If you are familiar with the AI, you will easily understand, right? You have a really nice training data set. It's okay. But if you have a really, really strange exception, what happens? This is the challenge of this problem. You want to say something? No? So here is anomaly. So we call this is anomaly labels. Okay. So for example, there is a cat and dog, right? You have a cat and dog. So you have a lot of image, a lot of training data set. This is cat, this is dog, this is cat, this is, so you have a lot of data set. What if there is a very strange animal, it looks like a cat and dog? What happened? You know what I'm saying? I'm trying to explain why this is important in real world, particularly. In theory, it's okay. In theory, it's okay, but in practice, in real world, you will have this kind of case so many times, okay? So, sometimes there is a very exceptional case with the anomaly labels. So, it's a very sparse. So, anomaly labels are very sparse, usually done by human experts manually, right? So, human experts try to simulate in the lab. Okay, this case, this case, this case, this case, this case, this case, right? And then they will have a lot of experience, a lot of knowledge, a lot of know-how, right? And then they will decide. You know what I'm saying? So this is, you know, most of case, human experts deal with these issues. But we are talking about AI, right? So in this case, fire alarm, normal room temperature was decided by human experts, okay? Every time. But my question is whether there is a very strange case, okay? You know, there is a sensor, okay? There is a sensor, there is a fire, there is a fire near the sensors. You can easily detect, right? But what if there is a fire outside the room? There's no sensors. What happens? You know what I'm saying? So I'm just trying to say always there is an exceptional case. So we have to consider anomaly detection. This is what I was thinking. Because otherwise, you know, So it's always important to consider the anomaly detection. And also, even with the labels, the anomalies are rare. Normal and anomaly data are extremely imbalanced. Okay? So in AI, if you take some machine learning course or AI course, you already have learned what is imbalanced issue, right? So you have a lot of, like I said, cat and dog. You have a lot of images for cats, but you have a few images for dogs, right? It's imbalanced. You have to always consider making a balance for the training data set, right? But like I said, some exceptional case, it's not easy to collect the data, training data. So you have to consider how to make the training data set balanced. Okay? So this is what I want to share. And also need to learn the high-dimensional data patterns of normal data. Okay. And the notion of anomaly is always subjective, right? So it depends on the experts. It depends on the AI system. Sometimes it's abnormal, but sometimes it's normal. Even in the same case. And it's vary from application to application. It depends on the expert, it depends on the application, it depends on the domain, right? So you will have different decision. And the boundary between normal and abnormal is often not precise, okay? So sometimes you say, oh, this is very abnormal. But sometimes it's not normal, right? Sometimes normal, sometimes it's not normal. So depends on how you design your systems, okay? Okay, so conventional algorithms, very well-known algorithms for anomaly detections, okay? So the first one is the classification. So you have enough number of training data set, then you can apply classification methods very easy, right? So here is the principle. You want to learn the discriminative boundary around normal instances. Okay, here I can assume that you are the Vietnamese, right? Some other nationalities. So I'm only the Korean in this room, right? So I'm the anomalies, right? You know what I'm saying? So nationalities, this is the key feature to identify normal and abnormal, right? So you can use the classification methods to detect anomalies. So in this case, multi-class and one-class classification problem. So multi-class classification problem, you can consider there are many different classes. Okay? So how can I? So for example, man and woman, right? This is binary classification problem, right? And what else? What else? And one class classification problem. This is nationality. So you are the Vietnamese and Korean. Okay? So this is one class classification. Like a spam filtering. You have normal emails, okay? But there is a spam email. So you want to detect which email is spam. This is one class classification problem. Okay? So anomaly detection is exactly the same with the one class classification problem. So we will see what is one class support vector machine later. I'm going to explain more details later. And second category is a distance. You will have a lot of data points in your space, X and Y, right? And then you can consider the density. So one of the well-known example is a k-means, k and n, right? K nearest neighbor. You can consider the distance between the data points. You can find out how can we make the clusters. Okay? You understand? Clear? Very easy, to understand. So you can use this kind of information, okay? Distance between the data points. And then you can find out, oh, this data is very far from the other data points. And then you can decide this is outliers. Outliers or normal data, right? So here is the LOF. It's a really famous methods. So I'm going to explain later again. LOF, K means PCA, you know PCA? The principal component analysis. This is also very well known for the high dimensional data set. You have a lot of features. Okay, some features is not important, so you can remove some not important features. Okay, so this is a PCA. So the classification problem methods, distance-based methods, and also you can consider statistical model, because some of you already know that statistics, right? Like a normal distribution, Gaussian distribution, Poisson distribution, right? There are so many different distributions, right? Statistical distribution. So you can use this kind of statistical distribution to identify which data is abnormal, right? So here is the Gaussian mixture model and the kernel density estimators. There are so many different ideas, so I'm not so sure how much time I have, but you will find out more details on the textbook. Okay? So we have seen that there are very well-known methods for machine learning, okay, for anomaly detections. And we want to formulate this problem, or how can I say, or in mathematical way. Okay, so here is anomaly detection algorithms with a generalized formulation. So in this case, you have to consider two parts. Okay, two parts. The first one is you have a lot of data, a lot of training data set. And then you have to consider how to learn the data representation. So you have some kind of data. Okay, here we have a student, and you will have some features like man, woman, heights, weights, and nationalities. Okay? So how can we learn these data? Okay? For people in this room, you have to decide it. Okay? And once you learn your data representation, you have to detect anomalies. And how can we do it in mathematical way? Okay? So here is the idea. So if you consider the representation learning, you have a lot of data. You want to know how to represent this data. Okay? So this is a mapping function. Okay? You want to map your data into a certain feature space. Okay? You understand what I'm saying? So we have like 200, 300 people in this room. You want to put your data, our data, right? Jason, some other students, put it in the feature space, okay? Because I want to find out what is the abnormal, right? You understand? So in this case, we are using the mapping function. It's a very, very basic idea in machine learning, okay? So here is x to y. X to y, this is predefined space, okay? So here is the latent space. This is what we have to learn, okay? This is what we have to learn, okay? And the second part, so once you learn what is the mapping function to represent your data, you have to detect the anomalies. Okay? So you can use some kind of score. Because for example K and N, we are going to see again, but K and N, you consider the distance, Euclidean distance between the data points. Okay? So this is some kind of score. How abnormal the data is. Okay? So in this case, you can have some kind of function like a d, okay? D pi x, okay? This is a function to measure how abnormal the data is, okay? And then you can use a distance threshold, like a room temperature is 80. So if the room temperature is greater than 80, you can decide this is fire, there is a fire. Okay? So in this case, you can use some parameters, okay, to decide these data points, this data is abnormal. Okay? So in this case, D is greater than delta, X is abnormal. Okay? Otherwise, X is normal. Okay? So this is like a very generalized mathematical formalism. Okay? So, like I said, we have two parts: learning your data and make a decision whether this data is abnormal or not. So, this is the process. Okay? So first, we have a mapping function to represent your data. Okay? So in this case, you have to learn the latent space. Okay? And then you will use some kind of score function to decide whether your data set, your data points is abnormal or not. So, like I said, this is, so for example, like I said, here we have 200 people, and I'm the abnormal, right? How can we do in mathematical way with this modeling? How can we do it? Just do it. Because I'm a Korean. So how can we use some kind of mathematical modeling to decide Jason is anomalous? How can we do it? Do you have any idea? Wow. No, it's okay, it's okay. you don't need to push. Okay? Don't do it. I don't like it. Just think about it. How can we do it? You have a Vietnamese, we have a man and woman, high and tall, small and big, wearing a glass or not. and also you are Vietnamese, I'm Korean. How can you decide I'm the anomalies? Do you have any ideas? Think about it. Homework. So this is a very general ideas. You can find out if you open your textbook or other, some papers, you will have this kind of equations in the paper, in your textbook, right? Yeah. So now I want to talk about some other methods, okay? Some other methods, and I want to talk. This method will be represented with this model. Okay? There are many different methods like a KNN, support vector machine. What else? A lot of different machine learning methods, but they are modeled in this form, in this style, in this way. Okay, so like I said, the goal is to decide. The goal is to estimate the parameters. Okay, I'm going to explain later. Here we have 3 different cases. Well, there are more different cases, but mainly there are 3 different cases. You have the labels in your training data set. You can apply, you can consider as a supervised approach, right? Classification problem, dog and cat. You have a lot of image data set in your training data, and all the data is already labeled. So it means that you can apply the supervised approach. And if there is no labels, you can consider this as unsupervised approach. Okay, this is some kind of clustering issue, right? So you have a lot of image files, but there's no label. You don't know whether it's a cat and dog. How can you cluster? Okay, so you need to find out what is the useful features, and you need to find out the distance between the animals, right? So this is unsupervised approach. And the last one is very interesting, sparse label. Sparse label. So you have a training data set, but only a few data has a label. So in this case, you can apply the semi-supervised approach for training. Anyone heard about the semi-supervised learning? Semi-supervised learning? No one? So this is also very famous and well-known approach when you have the very sparse labels. But anyway, I'm going to explain more details later. Okay, so today I want to talk about 3 different algorithms. Okay, the first one is support vector machine, also very well known, right? This is very well known approach, and also KNN, the K nearest neighborhood for the clustering, and the last one is the statistical distribution with the dynamic linear model. Okay, so I'm going to talk about 3 different algorithms to detect the anomalies. So this is the first algorithm for anomaly detection with the machine learning. So the first algorithm is support vector machine. So like I said, in this case, we have to consider one class classification problem. Okay? So support vector machine is very well known to consider the marginal approach. You want to consider the margin between the clusters, for example. Okay? Margin, you know the margin? Marginal. Okay? So in this case, you can see the two classes, class 1 and class 2, and you have some support vectors between 2 clusters, and you want to find out the optimal clustering. Okay? Optimal classification by maximizing the margins between classes. But in this case, the right hand side, you can see the one class classification. Okay. In this case, the blue one is normal class, and this is the outlier of normal patterns. Okay? In this case, you can consider one classification problem with a support vector machine. Okay? So another example. So in this case, you have to understand what is the kernel function. So particularly in support vector machine, you have to consider how to design the kernel functions to transform, right? So for example, from right hand side to left hand side, and also from left hand side to right hand side, there is some kind of kernel function to transform. Okay? So in this case, it's not easy to cluster, right? You don't have any. You cannot have any classifiers to separate the blue and red one, right? So you apply some kernel function to transform in this way, and in this case you can have a very easy to find out the classifiers between red and blue. Okay? So this is how the support vector machine is working. So in this case, you have to consider one classification to detect the anomalies. So like I said, we have to consider how to detect the anomalies in mathematical way. Okay? So we are talking about support vector machine. So here is the support vector machine for anomaly detection. So what is mapping function? So in this case, the kernel function is a mapping function because you have this kind of left-hand side. Okay? You have the data points, but it's not easy to separate the two classes. So you apply the kernel function to transform, which is the mapping. Okay? And how to measure the anomaly scores? So you can use W pi x to measure the distance. Okay. So in this case, this is the anomaly score function. So you can measure the distance between the normal classes and what is the distance between distance from the normal class for the anomaly patterns. Okay, and you decide if the distance is smaller than something, some threshold, and then you can decide this is anomaly. Right? Makes sense. And another well-known clustering methods, KNN. So in this case, we have the local distance functions to measure the distance between the data points. So in this case, you have the A. So in this case, A is the center of the cluster, right? So you have the cluster for A, and then there are a lot of data points. You get the B. Okay? So you need to find out the distance, okay, for measuring which data point is abnormal. So again, we are using the mathematical representations. So as a mapping function, there's no mapping, right? So we are just using the x and y, the coordination, okay, for the data points. We don't have any mapping function here. As a anomaly scores, we are using LOF, local outliers. Here's the equation. So local outlier factors. So we are using this equation to identify which data point is abnormal or not. So if the LOF, the local outlier factor, is greater than 1, you can decide this is abnormal. Okay? This is, otherwise it's normal. And another example, statistical distribution. So here is the, every year you have some kind of like a sales or some kinds of weather. Okay, you can consider the temperature, okay? You see, you know what I'm saying? So every year the temperature is changing like this, okay? For example. So you can use some mapping function by using some statistical distribution. Okay? So if you consider the statistical distribution, you can find out some parameters. Okay, theta, V, W, and so on, right? And then you can have the prediction error with this. Okay. I'm going to explain more details with the climate change tomorrow, but okay. Is it summer? Okay, in Vietnam you have a rainy season and dry season. Am I right? You have a spring, summer, fall, winter. Do you have? No. You have? Okay, I didn't know that. Okay, anyway. The winter is cold, summer is very hot, right? So we are repeating every year, right? Summer is hot, winter is cold. So, can you guess the temperature of summer in statistical way? For example, 80%, the temperature in summer is 30 degrees. You know what I'm saying? You understand what I'm saying? But what if the temperature of this summer is 20? What happened? What do you think? This is abnormal, right? We are supposed to think that we will have 30 degrees during the summer, but this year 20 degrees. It's statistically this is abnormal, right? You know what I'm saying? This is what I'm talking here. So if the error, prediction error, is 30 degree, 20 degree, there is a 10 degree difference. So we can decide this is abnormal. This year we have an abnormal weather. So 11 tons. So what is challenge? So so far until now, I have been talking about traditional methods, okay? Support vector machine, KNN, some statistical models. We can use these algorithms to detect the anomalies. No problem, right? You have a data, you have algorithms, you have you can easily identify what is anomalies. Okay? But there are some challenges still. Sorry. There are still some issues. The first issue, if you have more complex data, more high-dimensional data, okay, now we are talking about big data, right? The era of big data. You have a lot of data, you have a lot of information, okay? So it's a very complex, very high-dimensional data. Can we apply the conventional, the traditional method for this? You understand what I'm saying? So that's why people are talking about deep learning. Like a KNN, not KNN, but like a RNN or a CNN or some deep learning architectures. Okay, because you have a very complex data set. Okay, so from this very complex data set, you want to find out which data is abnormal. This is what we want now. Okay. So you have a very complex, very high-dimensional data set, and they are very coupled. They have a lot of strong dependencies between the data set. This is the problem, very complex. And so we are considering, so can we make some generic, some general model for this complex data set? This is what we want. And compensate with a sparse label, because we don't have enough labels, okay? Whether there is a fire or not, okay? This is very simple example, but you can consider many different cases, okay? For the building management, for the traffic, okay? Okay, can you open the next file? Can we have a 5 minutes break? Maybe it will be better to focus. I will be here tomorrow again. Also, if you have any questions or comments or some nice idea, send an email. This is my email address and my websites, and you can find out more details. So far, what do we have to talk about this morning? So the basic concepts on anomaly detection. Okay, so you have a lot of data. Sometimes you have a label. Sometimes you don't have any labels. Okay, but in each case you can apply different algorithms like a KNN or support vector machine. Even other methods. Okay, random forests. Now we are talking about some neural networks, but you can apply many different algorithms to detect anomaly detections. But you always need to consider how to, remember the previous slides, there is a kind of mathematical representation of your algorithms, okay, to detect the anomalies. So we have seen the one classification problem with support vector machine, and KNN for anomaly detection. We are using the LOF, the local outlier factor, very well known, and some statistical distribution. Okay, so you can use a statistical model to detect anomaly detections. But there is a problem. Since we have a very complex, large-scale data set nowadays, so it's not, so the conventional algorithms, they are not efficient, okay, for detecting the anomalies. So the second part of today's talk, I'm going to talk about deep learning architectures. So this is really hot topic in deep learning communities. So people are considering how to apply the deep learning architectures for detecting the anomalies. So somehow we can improve the performance more efficiently, like detect the anomalies. Okay? So here is the basic architectures for deep learning. So like a multi-layer perceptron, like you have a neural network structure, and you can consider the perceptron model, right? So I will show you later. And also the CNN, like convolution neural network. CNN is particularly strong with the image data set. Okay, so you have a lot of image data set, and you want to find out which image is abnormal. Okay, like for example, like a surveillance system, like from CCTV, you want to find out which image is abnormal. Okay, so and the last one is the recurrent neural network (RNN). This is good at time series data. You have a data stream over time. There's a new data coming, and you can apply the RNN to find out when we have the abnormal patterns. Okay, so this is the main ideas. And using the deep learning architectures, we will see deep one-class classification problem. So we want to extend the support vector machine with deep learning architectures. So I'm going to talk about more detail. And also, very well-known model, the autoencoder. So we can use the autoencoder for anomaly detections. Okay. Okay, there are more ideas, but maybe if we have a chance, I'm going to prepare more talk tomorrow with more ideas. Okay. So this is the multi-layer perceptrons, multi-layer neural networks. Okay. So here you have the neural networks like neurons and layers. Okay. So in this case, we can learn not only the linear patterns, but also non-linear and hierarchical discriminative features. It sounds very strange, right? But the neural network is very strong with the non-linear data, right? So we have to consider how to learn the non-linear, like exclusive OR, right? Exclusive OR problem. You can consider multi-layer neural, multi-layer perceptrons to learn this non-linear data set. And also, this is from the very high dimensional data set, right? So in this case, each layer takes a linear combination of previous input and apply activation functions, such as sigmoid and ReLU and tangent. Okay? So this kind of activation function can handle the non-linearities, okay, of the data. Since you have a really, really complex data, like a high-dimensional data set, you can increase the number of neurons and number of layers, and you will have better results, right? So of course, to train your data, it takes some time, right, for the training, okay? This is just a very simple example for the multi-layer perceptrons. Okay, you have a data as an input. Okay, okay. There is an input in the first layer, and there is a hidden layer between the input layer and output layer. Right. So you have a hidden layer, and as an output, you can say. Maybe today's example is Korean and Vietnamese. Okay. So you have an example like name, gender, height, weight, and nationality, and you can find out he is Korean, he is Vietnamese as an example. So, like I said, we have to consider how to model, how to represent deep learning algorithms for anomaly detections. So in this case, we are using multi-layer perceptron for feature extraction. So we can find out which feature is more important than the other features. Okay. So as a mapping function, we are using MLP, like a multi-layer perceptron, to detect. To find out which feature is most important, right? So anomaly score is same with the KNN, okay? And distance threshold is also the same with the KNN. But like I said before, there is no rules, there is no absolute rules for anomaly detection. So it depends on the situation, it depends on what kind of data you have, what kind of goal you have, okay? So depends on the situation, you have to decide, oh, in this case, I want to apply KNN. Oh, I want to apply multi-layer perceptron. Okay? So you design your own system, your own methods like this, and then you can detect the anomalies more efficiently. Okay, so this is what I was explaining. Okay, another example. So in this case, you have a training data set. The laser is not working, I'm sorry. DNN, the deep neural network, you can regard DNN as a multi-layer perceptron, okay? So you have the you have the feature extraction from DNN. So which feature is more important than the others? If some of the features are not important, you can remove. Okay, you can reduce the dimensionality of the data. Okay, and then you can have some subsamples. Okay, to identify which data is abnormal or not. So this is some kind of ensemble approach. Ensemble, you know, ensemble combination. Okay, so you have several different subsets. Okay, and then you can detect the anomalies. And then finally, there are many decisions of this data set is abnormal. Okay, and then you can finally decide this is abnormal. This is like ensemble approaches. So this is very well-known architecture, very simple architecture, right? To detect anomalies with feature extraction by MLP. The next one is CNN, the convolutional neural network. Maybe some of you already know that CNN. What is CNN? And I just asked ChatGPT what is CNN, and I have an answer like this. Okay, CNN stands for convolutional neural network. It is a class of deep neural network primarily used for field of computer vision. Like I said, this is very strong with the vision. What is the framework from Google? TensorFlow or some very well-known open sources, they can use CNN to recognize the pattern recognition for image files. Okay. So such as image recognition, object detection, and image classifications. And CNNs are designed to automatically and adaptively learn patterns and features from input data, making them particularly well suited for testing of visual data. So CNN is very strong with the image data set, right? So you can use a CNN for detecting the fake images, okay? So CNN is composed of 5 components: convolutional layers, fooling layers, fully connected layers, activation function, weight sharing. I don't want to go details. I can give you some example with this example. So you have an image, some birds, okay, some bird, and then you can have, all the image can be represented as a matrix, right? Matrix, two-dimensional matrix, okay? So you can use convolutional pooling layer to represent the image files, okay? So you can identify this image is a bird, like a cat or dog, right? You know what I'm saying? It's a very well-known examples for CNN. So in this case, you will have a high score with a bird, like a classification as an image classification issue, okay? And you have a lot of image file in training data set, like a bird, cat, dog, and finally once you finish your training, you will have a score, the weights between between the neurons, which is the weights, right? Weights between the neurons. This is how CNN is working. But okay, maybe this is the question for you. You have a lot of images. You want to detect which image is fake or which image is abnormal. Okay? You know what I'm saying? There is a lot of birds. You have a lot of bird image files for birds, and if there is a very strange image, you cannot identify this object. What this object is? Okay? This is what I'm talking with the CNN. So you can use a mapping function with like this, okay, CNN, and also the same with the anomaly score. Okay, if there is the distance between birds with a very strange image, if the distance between, here is the D, right? Prediction error is greater than something, greater than tau, you can say, I can identify this image, whether this is bird or not, right? This is how CNN is working for anomaly detection. The next one is RNN. RNN can learn and recognize complex context and model sequence structure. So you have to understand RNN is strong with sequence. Okay, A, then B, then C, then D. Okay, this is sequence. So RNN, recurrent neural network, is very strong with a time series or sequence of data. Okay, ordering some data is ordered. Okay, like a stock price. You know stock price. Okay. And some temperatures, room temperature. Okay, it's a time series data. And what else? The weather data also, right? It's a time series and it's a dynamic data. So in this case, RNN is working very well. Okay, so the well-known example, well-known algorithm is LSTM and GRUs, gated recurrent units, right? So the previous one is LSTM, okay? LSTM, and the next one is GRU. So if you are familiar with the time sequence or sequential data set, you have to apply this kind of model to detect, to train, okay? So they're the same. So you can use LSTM or GRU for detecting anomaly detection. So in this case, the predefined space or latent space will be the same. So you can apply LSTM, and anomaly score is the same. Okay, the weather in the temperature, right? The temperature is higher than the other time. You can say this is anomaly. Room temperature is also same. In normal case, we have a 20-30 degree maximum, but if it's 50-60, we can say this is fire, right? So if you consider the anomaly score, you can measure the distance. And then you can use this kind of function, mathematical function. You know, this is a matrix, okay? You have a time sequence, and then you can consider you can represent your time series data with a two-dimensional data, and then you can use this function to distance threshold. See? Okay. So what is the insights? So this is very well-known algorithms for deep learning, right? So RNN, CNN, this kind of algorithms, you can already, you might have some experience already, right? So you can consider this kind of deep learning architectures to detect the anomaly patterns. And what is the insights? So deep learning models such as MLP, CNN, RNN can better capture data representation, especially CNN, RNN, to capture data spatial and temporal dependencies. So what I'm trying to explain here is you have to consider KNN, what else? Statistical models. They are good, right? They are good, but the problem is you have a really, really complex data set. So in this case, you have to consider MLP, CNN, RNN deep learning architecture to solve the problem, right? So in this case, RNN, CNN, very good at understanding the dependence between the spatial and temporal. You know what I'm saying? It's really important, because if you don't understand what I'm explaining here, tomorrow will be difficult, because I will talk about some applications with RNN, how to detect anomalies from temporal data set, right? So I hope you can understand what I'm asking. So deep learning is really, really good for understanding the spatial and temporal dependencies. And we can use the deep learning models as a mapping function. Okay, if you see here the mapping function. So mostly deep learning architectures, deep learning models are applied for mapping. Okay, you have a really complex data set you want to represent somehow, right? But KNN and statistical model cannot do it. So that's why we are using deep learning models to map for the mapping. Okay? This is what I'm here put it here in the second issue. Okay? So deep learning model extract features as an input for traditional anomaly detection methods. Okay? Yep. Okay. I need to talk about some dependencies here. What is dependencies? What do you think? You have a lot of data. There is a temporal dependencies and spatial dependencies. What does it mean? What do you think? What do you think? Yep. There is a guy who wants to talk. What do you think?
Alright, I would say that these dependencies means that depending on means that if different location and different time frames may yield different results.
Okay, some other ideas?
So, at one, for example, at one country, doing one thing is legal, but in another country, it might not be legal. So, yeah.
Okay, thank you for your comments. Some other students. So CNN, in this case, this is I already explained that CNN is very strong with image files, image data, right? So in this case, CNN is very strong with the spatial, understanding the spatial dependencies. Okay? The position, the space, okay? And RNN is very strong with the temporal dependencies. A is before then B, okay? After C and D, you know what I'm saying? The temporal dependencies. The spring, and then summer, and then fall, and then winter. You know, this is temporal dependencies. The temperature, okay, is going high. During the daytime, the temperature is higher. At nighttime, the temperature is decreased, increased, decreased. Okay? This is temporal dependencies. And RNN is very strong with understanding the temporal dependencies. This is what I'm talking. Okay? So now I want to talk about several examples. So how can we apply the deep learning models to detect the anomalies? So I prepared two examples: the deep one-class classification problem and autoencoder. Okay, the first one is a deep one-class classification problem. So it's very easy to understand. Okay, if you understand what is support vector machine, like I said, there is a kernel function. Kernel, you remember kernel? So yeah, on the left side, there is a data points, your original data. Your original data, and it's not easy to separate the data, right? You see? It's a non-linear, right? So you have to transform your original data into in the figure in right side, okay? And then you can easily find out the black circles is normal, and the white circles are abnormal. Okay, this is one classification problem, right? But in the middle, if you have really complex data, it's not easy. Your corner function is not working properly, right? So instead of original corner function, you apply some neural network architectures, okay? To extract some features, you train something, you can use deep learning models for extracting features before your kernel function, okay? So once you have the features, you can apply the kernel functions, and then you will have a better results. You know what I'm saying? So this is a deep one-class classification. The paper was published like 5 years ago, and everybody uses this model nowadays. It's very powerful, working very good in many many data sets, right? So you can consider this kind of model for the one-class classification problem. So, like I said, the for the mapping function, you don't need to apply the kernel function directly because the data is really complex. Okay? So you can use some kind of neural network architectures, neural network models for the mapping instead of kernel. Okay? And then you will have an anomaly score and some distance ratio. Okay? So what about the autoencoder as a second example? Autoencoder is very easy to understand. It's very well known. So you have a input data on the left side, and you encode because you want to reduce the size of dimensionalities, right? You want to reduce the dimensionality, and then once you have encoded data, you want to decode, right? So because you want to reconstruct, right? So in this case, you can apply autoencoder. In the middle, you have a latent space. Okay. So the goal is to. Okay. Here is the description of what is the autoencoder. So autoencoder is inducing a latent representation to enable dimension reduction. You want to reduce the dimension, and as an output, you want to reconstruct the data. Okay? And the most important goal is to minimize the reconstruction loss. So you have between input and output. So this is how it works. I mean, you want to reduce the dimensionality, right? So, for example, the image file is really huge, right? So you want to find out which parts of the image is more important, right? Some parts are not important, right? So if you see cell phone, if you see the flower, you can easily identify this is flower. AI also saying you want to remove some features which are not important, right? This is why we have to consider autoencoder. And then you want to minimize the reconstruction loss, okay? Which is the difference between original and reconstruction. So this is exactly the same. So you have the encoder and decoder in mapping function. Okay. So and then you will have the anomaly score and thresholds like this. And then you can easily understand, oh, there is an anomaly by using autoencoder. So maybe this is somehow like if you have a fake image of the flowers, how can we detect this is fake? Okay, so you can find out by using the encoder and decoders, and if the difference between original file and training data set and testing data set, you can decide this is the anomaly. Okay. Okay. Maybe this is the end of talk. I just finished earlier than the schedule because I was expecting, small size of groups. I was expecting more discussions, but it's okay. If you have more questions, I will stay a little bit more so we can discuss. And also, if you have any question, comments, suggestion, I will be happy to discuss. Don't hesitate. We can talk. Right? Thank you very much. If you have any question, I will be happy to answer. Yep.
Hello. You have said that CNN should be applied to spatial dependence data, right? And RNN is for temporal dependence data. And what about autoencoder? In what case should it be used?
Yeah, that's a good question. Autoencoder is more general. You can apply, you can consider the spatial and temporal dependencies with the autoencoder. So I didn't actually prepare the more slides with the autoencoder. But if you see the generative models, like VAE, so variates autoencoder, so you can put some temporal and spatial dependencies to detect anomaly detection. You can use autoencoder also. No problem. It's a very general model. Okay? So other questions?
Thank you.
Professor, I have a question. As far as I know, RNN is really strong for temporal dependencies, like time series. But what about what's in a sentence? Like
So,
they have a dependence. So I was wondering whether RNN can be used for detecting.
That's a good question. Yeah. So he was asking what is the temporal dependencies? What do we have to detect? How can we? What will be the abnormal patterns in temporal dependencies? Like I said, the spring, summer, fall, winter, we know that there is some kind of typical weather conditions, right? For example, in Korea, during summer we have a lot of rain, okay? But this year we don't have any rain. So based on temporal dependencies, we can decide this year we have no rain, so this is abnormal. See? So in normal case, there is no fire. We know that the room temperature is between 15 to 20. Okay, this is normal case, normal situation. But if there is a fire, we have a very strange room temperatures. We don't have any dependencies in these cases. Right? So this is called the temporal dependencies. And how can we use a temporal dependence to detect abnormal patterns? Maybe tomorrow I'm going to talk about more details with my applications. Okay, thank you for the questions. Any other?
Thank you, Professor. But my question is, now I have RNN and the anomaly detections. Can I detect, for example, I have a sentence, which contains many of words, and can I use RNN and anomaly detection techniques to detect whether this word is appropriate or not? Like
that's interesting points, I think. So he was talking about the sentence. We have some sentence, and if there is a very strange words in this sentence, how can we decide this is strange or not? Theoretically, I think it's possible. So we can use some. Okay, first we need to have some natural language processing, and then we can identify these words. A very strange distribution, statistical distribution. Nobody used this word in this context. Then we can say, oh, this word is very strange. So we can use LSTM or some, what else? Some skipgram models to detect the word in a certain sentence, strange or not. Yeah, I think it's a very interesting point. Especially in social media, people are using very strange words, right? So maybe in this case we can apply these ideas. Any other ideas, questions? Okay, so no more question. Maybe I can close today's talk. Maybe I will talk more details tomorrow in the morning. Thank you very much. See you tomorrow.
Thank you very much for your presentation. And please, at the stage, and receive a gift from our student. Yeah, please. Please, in the middle of the stage. Anh Hà chuyển của em đến màn hình cái. Sau đây thì mời tất cả các bạn mình sau đây, các bạn mình cũng lên sân khấu đây chụp kiểu ảnh với cả chuyên gia nhé.